Okay, so question number 11 is the slope of a line is double of the slope of another line. If tangent of the angle between them is 1/3, find the slope of the lines. So basically you have some line, for example. Let's suppose that you have a line over here, just a hypothetical situation. For example, let's say that this line over here, 1, 1, and this line over here. So you see that this line over here, the slope is 1, and 1, 2, the slope of this line is of course 2. Over here, this is the y-axis, this is the x-axis. Over here, m is equal to 2. So basically the slope of this line is double the slope of this line, right? And the question is, the slope of a line is double of the slope of another line. If tangent of the angle between them is 1/3, so the angle between them is so now the angle between these two lines is going to be basically there are two angles over here. There is an acute angle. There is whenever two lines intersect, you have basically, there is a situation like this. For example, let's say that, for example, you have these two lines and they intersect at this point, and they have some slopes over here, and you always get this acute angle, which is equal to this angle, and you also get this obtuse angle, which is equal to this angle over here. These are vertically opposite angles, their measures are equal. So this angle is, let me do this again. Okay, so let's say that you have these two lines over here. And these two lines are intersecting on a xy plane. So you have basically these two angles that are equal, and basically this is an acute angle. You also have another angle over here, which is an obtuse angle. Now if I call this angle, for example, beta, and if I call this angle alpha over here, alpha plus beta is always going to be equal to 180 degrees. Now, the question says that if the tangent of the angle between them is 1/3, so if the tangent of the angle between them is 1/3, find the slope of the lines. So the tangent of the angle between them is equal to 1/3. So you want to find the slopes of the lines, and of course these are just hypothetical values that I put over here. Now let's go back and see. Basically, we had this concept over here. This concept over here, which was basically So basically, before we start with this question, so let me just give you some background about the angle between two lines, and then we will solve this problem. I will leave this question over here, and we will go and solve. We will go and take a look at the angle between two lines, and then we come back and solve this problem. So basically, there is some theory that we need to cover here. Basically, whenever you have two lines in a let's say that you have two lines in an xy plane. You have two lines in an xy plane. There can be only two cases. Either the lines are parallel, meaning that you have, for example, two lines like this, or basically you have two lines like this that are intersecting, meaning that, for example, there is some point over here, and that's the point of the intersection of these two lines. So now the case that the lines are parallel, of course, is not the case that we want to talk about here. We want to talk about the case where the lines are intersecting, and of course we want to discuss the angle between the two lines. Basically, there will be this angle over here, which is an acute angle over here, and there is this angle over here, which is an obtuse angle, and there is some sort of relationship between this acute angle and or this obtuse angle, whichever one you want to consider, and the slope of these lines. And the slope of these lines is, of course, as you know, basically related to the inclination of these lines, meaning that, for example, if you take this angle as, for example, some angle as some theta, for example, or if you take this angle as some theta, for example, then by definition we said that this angle theta, if you take the tangent of this theta, that's going to be equal to, we called it m, and we called it the slope of the line. The slope of the line. And what that means is that basically what this tangent of theta means, basically whenever you have let's say that you have a right triangle, something like this, and in this right triangle, if you have some angle theta over here, this angle theta is going to be, the measure of this angle theta is going to be related to how steep this line is, meaning that the larger this angle, the steeper this line is going to be. For example, I can draw this, for example, this way, and then in that case your theta is going to be a much smaller angle, and the line is going to be less steep. Over here, as you can see, as theta grows, the line is going to be steeper and steeper until you get to basically 90 degrees over here, which is, of course, at this stage, then basically we can forget about this side of the triangle. But essentially, if this line goes all the way up to 90 degrees, at this point the slope of the line is not defined, and then you can of course just keep going and in this direction, and you will get larger and larger thetas, but in that case now the slope of the line becomes negative. So So what that means is that this theta is going to determine how how steep this line is, and how steep this line is mathematically is called the slope of this line. And there is a way for us, fortunately, I mean, luckily there is a way in mathematics to basically to measure how steep this line is in terms of the ratio of these two sides, meaning that if you divide this side of the triangle, let's call this, for example, ABC. If you divide this side BC, if you take the ratio of BC to AB, the larger the numerator, of course, the larger is going to be the fraction, meaning that the larger is meaning that the angle is going to be bigger and bigger, meaning that the more that you keep this AB constant over here, and the more that you make this that you make the numerator larger and larger, the larger is going to be the overall value of this ratio, and with that this theta is going to, of course, is going to grow, and then with that, of course, the slope of the line is going to be steeper and steeper. And of course, in this triangle, you know that if you want, there are some trigonometric ratios that we have of this triangle. For example, we have sine of theta is BC by AC, is the opposite to hypotenuse, is BC to AC. Or basically we have also another trigonometric ratio called cos of theta, which is AB divided by AC. AB divided by AC. Now you know that if I write sine of theta and if I divide it by cos of theta, this ratio is technically called, in mathematics, of course, it's called tan of theta. And it's going to be equal to BC by AC, BC by AC to AB to AC, to AB to AC. And of course then you can simplify this and you will get BC to AB, which is basically what we got over here. So that means that BC to AB, which is the ratio of this side to this side, is actually tan of theta. And so that's basically why this tan of theta has been called M, or the slope of this line. So now what that means is that basically now with this background in mind, let's go back over here and consider a situation in which we have basically two lines, for example L1 and L2. Let's say that you have this, let's say that you have two lines L1 and L2 that are basically non-vertical. So you have two non-vertical lines L1 and L2. You have these two non-vertical lines L1 and L2, and I'm going to call the slope of this line M1, and I'm going to call the slope of this line M2. And there is something which I suppose I forgot to mention here. There is something called the inclination of a line. There is something which is called the inclination of a line, and that is basically, if you have a line over here, let's say that you have this line over here, and if you have this line, basically if this is the x-axis and this is the y-axis and this is your line, let's call it, for example, line L, the angle that the line makes with the positive direction of the x-axis with the positive direction of the x-axis measured in anti-clockwise direction is called is basically, sometimes you can call it anything. You can call it theta, you can call it phi, you can call it beta, or whatever you want to call it, but this angle is called the inclination of the line. For example, you can see that, for example, this angle over here, of course, is not the inclination, but this angle over here is called the inclination of the line. Now, so now the inclination of this line L1, I'm going to call it, for example, alpha 1, and the inclination of this line, I'm going to call it alpha 2. These are the inclinations. These are the inclination of these two lines. These are the slope of the two lines, and these are basically the lines themselves. Now, as we discussed here, whenever two lines intersect in an xy plane, they make two pairs of vertically opposite angles. So this is one pair, and this is one pair over here. So two pairs of vertically opposite angles. And when this kind of thing happens here, two pairs of vertically opposite angles, you have these two angles and these two angles. Any two adjacent angles, the sum of any of these two adjacent angles in this combination of angles is going to be 180 degrees, right? Now if I take these two angles, let me clear this up. So let me call, for example, this line, I'm going to call it L1. I'm going to call this L2. So this angle over here becomes basically alpha 1. This angle over here becomes alpha 2. And so I'm going to call this, for example, this angle over here, I'm going to call it theta. And I'm going to call this angle phi, for example. Now, so now what happens here is that if I call these two angles theta and phi between the two lines L1 and L2, then of course I can write theta is equal to phi 2 minus is equal to alpha 2 minus alpha 1. I can write basically theta, this angle over here, I can write theta is equal to alpha 2 minus alpha 1. And the reason why I can write this is that basically, you know that if this angle is theta, this angle is also going to be theta. And of course, this is a triangle over here. This is a triangle. This is alpha 1, this is theta, and this angle over here, you can call it, for example, 180 degrees minus alpha 2, because this whole angle is 180 degrees. So you know that theta plus alpha 1 plus 180 degrees minus alpha 2 is supposed to be equal to 180 degrees, because it's the measure of the internal angles of a triangle. And then you can simplify these two, and then theta is equal to basically negative alpha 1 plus alpha 2, or you can write it as alpha 2 minus alpha 1, which is basically what I have written over here. Theta is equal to alpha 2 minus alpha 1 in this construction. So I can write basically theta is equal to alpha 2 minus alpha 1. Theta is equal to alpha 2 minus alpha 1. And And of course, there is something also about the measures of alpha 1 and alpha 2, which is not that important right now here. So I can write basically, I can write here tan of theta is equal to tan of alpha 2 minus alpha 1, because the angles are equal. And tan of alpha 2 minus alpha 1 is, you know, the tan of alpha minus beta is equal to tan alpha minus tan beta, 1 plus tan alpha tan beta. Okay, so based on this formula, you can write this as tan of alpha 2 minus tan of alpha 1, 1 plus tan of alpha 2 tan of alpha 1. And of course, tan of alpha 2, we defined it to be m2. So I can write this as m2 minus m1, 1 plus m2 times m1. And of course, you know that here basically 1 plus m2 times m1 is not supposed to be equal to 0. And it can never be 0. So here I can write as 1 plus m2 m1 is not equal to 0. So this is basically something that you already know. Now there was one more angle over here, which was basically called phi, which you can call it as which you can basically, you know that theta plus phi is equal to 180 degrees. So then phi is the same thing as 180 degrees minus theta, and tan of theta was basically let me see what we have over here. So over here we calculated tan of theta. Now tan of alpha, if you want to calculate that is equal to, based on this, is equal to tan of 180 minus theta, which is equal to, basically you can write this as negative tan of theta. And the reason for that is that basically tan of 180 minus theta, you can use the same formula that we had up here. Tan of alpha minus beta is equal to tan alpha minus tan beta, 1 plus tan alpha tan beta. So I can write this as tan of 180 degrees minus tan theta, and 1 plus tan 180 degrees tan theta. And tan of 180 degrees is basically tan of 180 tan pi is equal to, see, tan of 180 degrees is the same thing as sine 180 degrees, which is equal to 0. Sine 180 degrees is equal to 0, and cos 180 degrees is equal to negative 1. So this becomes 0. So then tan of 180 tan pi is equal to 0 here, and this is also, this whole thing becomes 0. So you have negative tan theta. So then you can say that tan of 180 degrees minus theta, or you can write it as tan of pi minus theta. Tan of pi minus theta is equal to negative tan theta. Okay. So so what that means is that over here, instead of basically negative tan of 180 degrees minus theta, I can write negative tan theta. And so you have negative tan theta here, and negative tan theta is basically this, this multiplied by a negative sign, which is the same thing as negative m2 minus m1 over 1 plus m2 m1. And of course, again, 1 plus m2 m1 is not going to be equal to 0. And so basically, so far what we have is tan of theta. Basically, so far what we have is basically tan of theta is equal to m2 minus m1, 1 plus m2 m1, and tan of phi is equal to negative of, let me write this way, I don't want to confuse you or anything, so negative of m2 minus m1, 1 plus m2 m1. So that's basically what we got so far. Now there can be basically two cases over here. Of course, when we write basically, there you have two cases over here. Of course, when we write, for example, m2 minus m1 over 1 plus m2 times m1, 1 plus m2 times m1 can never be 0. It can never be 0. But m2 minus m1 over 1 plus m2 m1, the whole ratio or the whole fraction, can be it can be positive or it can be negative. So now, if basically case 1, which is basically this whole fraction, is positive. If this is positive and you know that this is equal to tan of theta, so then that means that tan of theta is positive. And if tan of theta is positive, that means that theta is, and of course when we said that basically tan of theta is the same thing as, you know, that tan of theta is the same thing as negative tan of phi. Negative tan of phi, as you can see over here. Tan of theta is basically this value. Tan of phi is the same value times a negative sign. So you can write tan of theta is equal to negative tan phi. So what that means is that if tan of theta is positive, then tan of phi is a negative value. Now you know that if you have a unit circle over here, if you go from 0 to pi, if you go basically from here all the way up to here, from 0 to pi, the tan function here is positive, and here tan is negative, right? So that means that if tan of theta is positive, then that means that theta is an acute angle between 0 to 90 degrees. And if tan of phi is less than 0, that means that phi is an obtuse angle. Okay, so that's basically about case 1. Now there can of course be another case which is case 2, which means that m2 minus m1 over 1 plus m2 m1, m1 is less than 0 or a negative value, in which case that means that tan of theta is less than 0 or a negative value, and as a result tan of phi is a positive value. If tan of theta is basically if tan of theta is a negative value, that means that theta is an obtuse angle, and that means that phi is an acute angle. So basically there can be only these two cases. Now what this practically means is that we have basically these two angles, theta and phi, between these two lines, and basically based on these two cases, you can tell whether basically your theta is the obtuse angle or the acute angle. And of course, based on that, of course, you can calculate it as well using this relationship that we found. And so basically, so for example, if I take the acute angle, now of course you can call it whatever you want to call it, but if I take the acute angle, for example, if I call it, for example, theta, the acute angle, if I call it theta, and that basically, which is basically between the two lines L1 and L2 that we talked about, and the slope of those lines is M1 and M2, and you already know about that. So the acute angle, you can calculate it using this relationship. Tan of theta is equal to basically tan of theta, since basically this relationship over here can be negative or positive, I take the absolute value of that and I write it as m2 minus m1 over 1 plus m2 m1, and that's going to that is going to give me a positive value, right? That is, whether this is a negative value or a positive value, this is going to give me a positive value. And of course then that's going to give me tan of theta, the tan function is going to give me the meaning that the tan function is going to give me the acute angle. And then once you have your acute angle, then the obtuse angle, say for example phi, you can calculate it using the relationship that there was between theta and phi. We said that theta plus phi was equal to 180 degrees. So that means that phi is equal to 180 degrees minus theta. And that's basically all there is to it. So the tan of theta is equal to the absolute value of m2 minus m1 over 1 plus m2 m1. And then once you have that angle, then you can, based on that, you can use the other angle as well, and then the whole problem, the whole basically story is basically that. So now that we know this, let's go and solve the problem that we had regarding the two, basically this line over here. And we said that basically the slope of one line, the slope of a line is double the slope of another line, and if the tangent of the angle between them is 1/3, which is basically what we had over here, we said the tangent of theta is basically some value over here. If that is equal to 1/3, then what is the slope of the two lines? So we can simply use this relationship to calculate that. Okay, so now if I know that tan of theta here, so if I know that tan of theta is equal to, for example, tan of theta here is equal to 1/3, as we said over here, and basically, let's say that, for example, M2, let's say that M2 is equal to 2 times M1, something like that. Then based on that, you can calculate both M1 and M2. Meaning that wherever you see M2, you substitute that with 2M1 in the formula that we had. Tan of theta is equal to the absolute value of M2 minus M1, M2 minus M1, 1 plus M2 M1, 1 plus M2 M1. And so basically, let me see if I written the 1 plus M2 M2 and so 1 plus M2 M1. Okay, so now if suppose that for example suppose that you now tan of theta is equal to 1/3, is equal to the absolute value of M2, which is equal to 2 times M1 plus minus M1, I'm sorry, minus M1 and 1 plus M2 M1. So M2 is equal to 2 times M1 times M1 times M1. And that is equal to, so 1/3 is equal to the absolute value of, 2M1 minus M1 is equal to M1. 2M1 minus M1 is equal to M1. And that is 1 plus 2 times M1 squared. 2 times M1 squared. Now what this means is that basically when you have the absolute value function, the absolute value function is basically another way of saying that the distance of some point from some other point is some quantity. For example, if I say that the absolute value of x minus a is equal to, for example, b, what I'm really saying here is that the distance between x and a is basically, for example, is for example b, meaning that if I say that, for example, x minus 2, the absolute value of x minus 2 is equal to, for example, 2, what that, or 3, for example, what that means is that basically x is a point x is a point whose distance from the point point 2 is basically 3 units, meaning that if this is a real number line, if this is 1 and 2, So this is 0.2 over here. So now x is a number whose distance from the point that refers to number 2 is 3 units. So you can go in this direction and you will find 1, 2, and 3 units here. So -1 is going to be one of the numbers, and 1, 2, and 3, so that's 3, 4, and 5. And so 5 is another number. And so you see that the distance between these two numbers, the distance between this number and this number, either of these two numbers from 2, is basically 3 units. And when we want to solve such equations, we say that if we have the absolute value of x minus 2 is equal to 3, we write it as, what this means is that x minus 2 is equal to positive 3, or x minus 2 is equal to negative 3. And so here x is equal to 3 plus 2 is equal to 5, and x is equal to negative 3 plus 2, which is equal to -1. So this is -1 and this is positive 5 over here. So you can do the same thing over here. Or if you want another example here, I can make it a little bit simpler, meaning that, for example, let's say that I say the absolute value of x, for example, is equal to 3. What I'm really saying is that in the previous case I said that the absolute value, for example, x minus 2 is equal to 3, and what this meant was that the distance between this number x and 2 was 3 units. So I can write this in the same way: x minus 0 is equal to 3, and what that means is that the distance between 0 and x is equal to 3 units. Meaning that if this is 0, 1, 2, 3, and 1, 2, -3, the distance between x and 0 is 3 units. So 1, 2, 3 units, that's one of the numbers, and this is the other number. So this is 3 units, and this is also 3 units. So again, over here, what you can do to solve this equation is that you can say that x is equal to -3 or x is equal to +3, and that's basically the solution set of this absolute value equation. So basically you can do the same thing over here, and a little more formally, what we say about the absolute value function, we say that the absolute value of x is equal to basically equal to x if x is greater than or equal to 0, and it's equal to -x if x is less than 0. Meaning that if you have if your x is negative, if your x is negative, then the absolute value of x is equal to -x, which is a positive value, and then if x is positive or 0, then the absolute value of x is equal to x, which is again a positive value, which is basically these two values over here are the distance that we had on the real number line that we just saw. So it's a little bit, I mean, unless you really understand it well, it can be a fairly confusing function. But otherwise, if you understand it, you can use it in many different situations for many different purposes. Now, if you have this kind of equation over here, this equation over here, you can write it as m1 over 1 plus 2 times m1 squared m1 squared is equal to 1/3, or you can say m1 over 1 plus, I think this is right, so 1 plus 2 times m1 squared is equal to negative 1/3. And in this case, what you have is basically 1 plus 2 times m1 squared is equal to 3 times m1, 3 times m1, which means that 2 times m1 squared minus 3 times m1 plus 1 is equal to 0. And and what that means is that basically if I choose 2 and 1, so if you want to solve this equation, you would have basically, to solve this equation, you need to multiply 1 and 2, which is 2 basically. Now 2 is the same thing as 2 times 1. 2 times 1. So you can have two numbers, 2 and 1. 2 and 1 over here. 2 times 1 is equal to 2, positive 2. And negative 2 and negative 2 times negative, negative 2 times negative 1 is equal to positive 2. And negative 2 plus negative 1 is equal to negative 3. So I can write this as 2 times m1 squared minus 2m1 minus m1 is plus 1 is equal to 0. And then I can write this as 2 times m1 times m1 minus 1 minus 1 times m1 minus 1. So here you have 2 times m1 squared, negative 2m1, and over here you have negative m1 plus 1 is equal to 0, and that gives you 2 times m1 minus 1 times m1 minus 1, m1 minus 1 is equal to 0. This gives me 2 times m1 is equal to, what that means is that either 2 times m1 minus 1 is equal to 0, or basically m1 minus 1 is equal to 0. This means that 2 times m1 is equal to 1, and m1 is equal to 1 by 2, or basically m1 is equal to positive 1. So these are the two possible cases for m1 here. And then over here you have m1 over here you have m1 over 1 plus 2 times m1 squared is equal to negative 1/3, which means that which means that for example negative 3 times m1 is equal to negative 3 times m1 is equal to 1 plus 2 times m1 squared, and 2 times m1 squared plus 3 times m1 plus 1 is equal to 0. And then you can write this as 2 times m1 squared plus 2m1 plus m1 plus 1 is equal to 0. And then 2 times m1 times m1 plus 1 plus 1 times m1 plus 1 is equal to 0. And that's 2 times m1 plus 1 times m1 plus 1 is equal to 0. And so that what this means is that either 2 times m1 is equal to negative 1, or m1 is equal to negative 1 by 2, negative 1 by 2, or m1 is equal to negative 1. m1 is equal to negative 1. Now, this is a different case. We will talk about it later. But over here, we said that basically m2 is 2 times m1. Now, if m1 is equal to m2 is equal to 2 times m1, we said that m2 is equal to 2 times m1. Now, if m1 is equal to 1/2, then m2 is equal to 2 times m1, which is equal to 1. So that's basically one possibility. If m1 is equal to 1, then m2 is equal to 2 times m1, which is equal to 2. And let's see if now over here, these two cases, if m1 is equal to negative 1/2, then m2 is going to be equal to 2 times that, which is negative 1. That is another possibility. Or if m1 is equal to negative 1, then m2 is equal to 2 times that, which is negative 2. That is another possibility. So you get basically four possible combinations of these slopes. So let me see if my answer is right, which was number, in the exercises it is number 11. Number 11 is 1 and 2, which is this case over here, or 1/2 and 1, which is this case over here, negative 1, negative 2, which is this case over here, or negative 1/2, negative 1. These four basically possible answers you could find for this question. Okay, so I think I'm going to end this video here, and then in the next video we will talk about question number 2. This was number 11, 12, 13, and 14. So I'll see you in the next video. Thank you.